So there's three more trends. They're pretty fast. They're not as in-depth as our other ones have been. But our first one here is electron affinity. Electron affinity deals with kind of the opposite of ionization. It deals with the fact of how much do you want an electron. So what you have now is you have a neutral atom, but instead of taking an electron, you're actually giving it an electron. So what happens here is it becomes negative, and you get energy. So metals don't tend to give you very much energy, so they're only slightly exothermic. They only release a little bit of energy. But non-metals tend to give you lots of energy, so they are very exothermic. They release a lot of heat. And if this little picture down here just shows you, here's chlorine. He's getting an electron. He's all happy, all this stuff. So what he does is he releases, that's why it's negative here, he's releasing 349 kilojoules per mole, which means you're getting that energy, and that's usable energy for whatever you need it to do. Has a very similar trend. If we look here, we're small on the left, we're large on the right, we're small on the bottom, and we're big on the top. And one thing you definitely want to write down, our noble gases do not participate. Again, they're kind of like abstaining. They're very royal. They have all the electrons they have, so you can hardly see it here, but it is on the graph here. They're not even on the chart. Like, it's just kind of a blank spot. But if you look otherwise, the trend does kind of hold. Second to last, electronegativity deals with the fact of when you're bonded. So this is when you're bonded to other elements. And it's a scale. It's not like measured in kilojoules or anything. This is something that scientists have come up to. The highest number on the scale is fluorine, and he's kind of like the biggest meanie. So what that means is that if you're the highest, if you're very electronegative, that means you pull electrons towards you. It's not really assigned to the noble gases again. It is actually derived from different data that they take. What we find is that metals have very low electronegativity. They don't really pull electrons towards them. Non-metals have very high electronegativity, and like we said before, fluorine is the big kahuna here. If you're looking at this, what we have here is we have hydrogen, oxygen, and chlorine bonded together, and these numbers are their electronegativities. So hydrogen's 2.2, oxygen's 3.44, and chlorine's 3.16. What that means is that oxygen is going to pull electrons towards him. Oxygen's going to pull electrons from chlorine. And what you get is this kind of like bump here on oxygen, which means he has lots of electrons. That's what this little delta negative is indicating. And what you can see on chlorine and hydrogen is they are delta positive because it's like they lost some of their electrons. Because oxygen's hogging them all, and hydrogen and chlorine kind of are like, okay, whatever. So these elements are sharing, but they're not sharing well at all. Oxygen's a big amino head, and that's what we know now. Same kind of trend as our last couple. So again, on the left, you're small. On the right, you're large. On the bottom, you're small. And on the top, you are large. And then again, one more time, you probably want to write it. Noble gases do not participate. So if you noticed, ionization energy, electronegativity, and electron affinity all have the exact same trend. So you're not learning 18 different trends. What you're really learning is how does a couple trends really fit together, and how are some things alike and how are some things different. And last thing for the periodic table is metallic character. And this is one you don't really think about, but they actually measure how good of a metal some things are. So basically, how good are you at losing electrons? Because that's really what they define as metals. If you think of cesium and francium, they will like basically almost throw electrons at you because they don't want them. So if you look at this, metals are on the left, so it makes sense that you're more metallic. You have a larger metallic character if you're on the left. and you have a smaller one when you're on the right. And then what we also find is when you're at the top, you don't have a very good metallic character. And as you get to the bottom, you have a larger metallic character. So technically, if you're looking at metals, the worst metal, the least metallic metal is aluminum. And the most metallic metal is cesium or francium. And again, if you remember, francium isn't listed sometimes because it's so reactive, it's almost hypothetical. We can't really mass it, we can't really contain it, just because it is so dangerous. So it's not like we're forgetting about it, it's just one of those things where, wow, it's really, really reactive. And the last slide here, you may want to write this down, draw it on your thing, just so that you realize that, you don't have to memorize 18 different things. You really just need to see the patterns, and that's what the whole periodic table is about. Again, this is different. This is, in some cases, difficult. So you're going to be working on this for the next couple of days, and you need to make sure that you're reading your book, you're reviewing, you're seeing where in the world does this all crazy stuff come from, because you have to be able to organize all these different crazy things into one.